Hi everyone. You probably know the title of the talk, so I will start from introducing myself. I'm Pasha, and this is actually my story. Usually I tell stories about other developers, their experiences, my experience with other developers, how I helped or how I found out something, but this is a completely different story. This is actually a story about me. So, as many of you, I was a usual user of ChatGPT. Like, who uses ChatGPT or Claude or anything? Yeah, thank you. Like, so, for like 2 years, I was too shy to say that I use ChatGPT in my work and, I don't know, everywhere to write letters to different amts here in Germany. I don't know any German. Well, I know some German, but I'm not any good in it. Guten Tag, is what I can say. And I really didn't care how ChatGPT works. Like, I mean, magic. I'm fine with it. There are a lot of magical things. What I mean by it, I didn't really care. So, like, it's interesting, of course, but there are a lot more interesting stuff around me. How to call my landlord and explain that my dishwasher is broken, or something like that, because again, my German is not good. And of course, I didn't know much about LLMs. Well, a large language model, how large, why large, I don't know. And of course, I didn't heard about RAG at some point. By the way, RAG stands for Retrieval-Augmented Generation. I'm giving this talk 5th time. I still can't remember its full name, so I will call it RAG. Sorry. The question, who is like me here, who doesn't really care? Thank you, thank you, thank you. Half of the audience is like me. So, folks, I will try in this talk to cross some T's, how it works from our developer perspective. I won't dive in convoluted maths or anything like that. Well, maybe a little, we'll see. Of course, I heard about neural networks, probably as all of you. This is what I heard. Who also saw this picture? Yep. What is this? I mean, do you understand any of this? I guess some of you, yes, but... So for me, this is, I made a mermaid diagram to explain how it looks for me. There is me, then there is a magical black box, and then there is output. Picture, something, text, whatever. And if you see, the architecture is very, very close. Me is on the orange layer, black box is on the green layers, output is on the red layer. And yeah, at this point, it's time to tell something about me, I guess. I work with JVM for almost 15 years. I used to be a back-end developer, data engineer, engineering manager, everything. And data engineers are actually very close to the guys, or girls, folks who do neural networks and all this stuff, but I still wasn't interested. I usually did performance optimizations for them. Like, they throw a bunch of Python or Java code at me and say, Pasha, it doesn't perform well enough for us. And I was like, okay, let me dig into it. So even without any knowledge of all the maths underneath, I was able to optimize something, and it is exciting. I like optimization, and of course, I worked with Spring and without it. I used to love Spring. I used to hate Spring. We have convoluted relations with Spring. Well, I mean, who else feels the same way on many levels? Yeah, like third part of the audience, which is beautiful. Please come in. Currently, I'm a developer advocate at Bellsoft, and this means I have a lot of time to experiment. I'm either on a conference, like this one, or I'm trying to build something interesting, or like, I don't know, write some code to stay hands-on, at least a little bit. And yeah, I need to produce a content for you, like it's my job. Like, it is in job description, right? And to produce content, I need to understand what are we doing. Like, everyone knows what Bellsoft does. We do Liberica JDK. Who uses Liberica JDK here? Okay, you should. Bad for you, what can I say? By the way, you can follow me on the social networks. The thing is, since we do JVM, free, open source, and so on, we have a lot of documents about it. We have a lot to say about JVM. We have documents, we have blog posts, some of them are even written by me. We have white papers. We implemented ARM32 support for OpenGDK, for the God's sake. Like, we are the people who did it. And since there are so many documents, I just couldn't find my way through them. Like, how do I understand, like, how this thing works? What are the I don't know, JavaFX? What subset of JavaFX do we support? How do I find it? And, well, so I decided to do something about it. And there are probably multiple solutions how you can approach to solving this problem of not understanding what's happening, not being able to read the whole documentation. You can try to put the documentation in Elasticsearch or into Google Desktop. Who knows Google Desktop? Yeah, you probably need your pain medications. I'm sorry, folks. Google Desktop is already dead for a long, long time. I found it out when I prepared this talk, actually. I started preparing this talk. Obviously, we can use good old grep, right? Well, just, I don't know, grab this word I'm interested in. And, well, grabbing PDFs is cumbersome, but surprisingly possible. You can put an OCR label with OCR My PDF application into any PDF. After that, it becomes easier. But I'm a developer. Like, I used to be a developer for a long, long time, and I know what I'm like. I don't know if you can relate. I don't know if you can publicly admit if you can relate. But what we should do is we should solve problems. What will we do? I will actually yak shave. Like, even if there is a ready-made solution for me, I will try to solve it myself somehow. Especially if I'm being paid for this yak shaving. Hopefully you can relate, but do not tell. But obviously, like, it was a boom of ChatGPT, so I was like, I need to use AI. Let AI understand my documents and let me query, to ask questions. That's what I use with ChatGPT. Why can't I use it with our document base? But how? Like, some of you can't say that, but surprisingly, I have a friend. His Twitter handle is here. And I can actually, since he is a good friend, I can actually ask him stupid questions. And I was like, how do I search through my documents? You do this neural network stuff for years, like literally, long before the whole boom, he was doing it. And he's a good friend, so he didn't try to give me a fish he tried to teach me how to fish. And he asked me, well, what do you know? And I said, I heard about word-to-vec, I heard about layers, embeddings. He goes, oh, embeddings is a nice word, he said. Like, explain me embeddings, he said. And I was like, numbers? Who do not understand what embeddings are? Thank you. Like, this is so supporting to feel that I'm not alone. So the thing is, embeddings are very, very simple and stupid. Here is an embedding, like the first line with doubles, and the second one, just an embedding set of numbers, array of numbers, whatever you want. What do they mean? Well, we don't know. In this context, they do not mean nothing. But actually, embedding is a representation of something in n-dimensional space. For example, if we want to represent physical points on globe, we have this longitude, latitude. We can take any point and say, this point, and this is point, and the embedding for this is array of two numbers. For example, for New York, it's 4.7 and 74.0. For Tokyo, it's 35.6. They're centers, but who cares in this context? 139.6. And this way, we can like collapse the name of New York and Tokyo into two doubles. Some of you will say it's not too much of a space saver, and I agree, but there are longer names like St. Petersburg or something like that. We can actually even try to save some space, storing not names but coordinates. So coordinates are on a physical space. Embeddings tell us where the things are in a meaning space. Meaning space is a very mathematically abstract, but we can say that most probably in usual meaning spaces, cat and kitten will be very close to each other, like New York and New Jersey, for example, and Ken and Rocket will be very far away from each other, like New York and Canberra, for example. Here's a small illustration. If we have points or vectors for king and man, and we deduce man from king, and then we add one more vector for woman, and king minus man plus woman becomes queen. Please? Yes, something like this. I hope you appreciate the video. It spent, 3 hours on it. This is the whole, honestly, this is the whole idea of how this vector space works. You can add and deduce vectors from each other, and this way understand how the terms are related. Obviously, this is a very simplified example, right? Or again, only two dimensions, and we can't even name these dimensions. But they give us the general idea. If you are not in the video, I have the same in text. For example, king minus man plus woman equals queen. Father minus man plus woman equals mother. Some of you will think that it's a stretch, and I agree. I'm very sorry. I tried to have simple examples. But the thing is, here we can see a very interesting idea that in this space, difference between father and mother is equal to the space between man and woman. And this is a fundamental idea of embeddings. They are the same vectors, which are somehow, somewhere in the multidimensional space, reflect, relations to each other. And yes, the parent concept stays even though the gender changes, which is a very interesting thing. Like, you should understand, these neural networks, they do not understand text. They only see relations, which words are close to each other, and somehow statistically deduce it out. And the first neural network to do this was called Word2Vec, or the first popular. It was introduced by Google in 2013, and it was a huge breakthrough because it was relatively small. I can run it on my machine, actually. Well, it's kind of obvious, right? It's 2025. It was 12 years ago. But what is important, it made it practical to capture word relations in vector space. Before that, it was crazy expensive. How it works, it tries to predict which words will appear next to each other. And it's not important which word was the first. Let's say that the first word was, cable. Then it will be the first word with some vector, and all other words will be predicted compared to this word cable, even unrelated ones, because actually all words are somehow related. And it can predict that sometimes cat and dog, usually cat and dog words will appear next to pet and food and vet, which means they are somehow semantically close, even though they mean completely different things. There are several key innovations in Word2Vec. First, it is much faster to train than previous methods. And second, which is actually probably more important, it produced higher quality embeddings. And yes, it showed that simple neural networks could capture complex meanings, even though it operated only on single words. And actually changed ways of NLP all current Google Translate and DeepL and whatnot are built on technology like this, probably more advanced. Obviously, 12 years has passed. It's a lot of time in IT, but still, it's a huge impact. What you should understand, the result of work of Word2Vec is a dense vector of numbers, and hopefully I have an explanation here. It's a compact numerical representation where most values are non-zero, unlike sparse vectors. Hopefully you all know this. I'm just not a technical guy, kinda. Well, it means that there are less zeros than anything else, than usual vectors you will see. Similar words have similar vectors, and vector math captures semantic relationships. This is what we saw on the video. Word2Vec produces vectors not that big, and again, vector is just an array or list, whatever you call it, of doubles. Usually it's 100 to 300 numbers, but it enables measuring similarity because we have mathematical ways to compare how close are vectors to each other. And it can be visualized in lower dimensions, exactly like we did in our video. Obviously, there are multiple technical limitations in Word2Vec. Its fixed content window misses broader document meaning. It means that if in our unique text the word chair means something completely different, the Word2Vec won't understand it. And it cannot handle polysemy. Like Schloss in Germany is probably not only castle, right? Maybe it's also a lock. And Word2Vec doesn't feel the difference. It also requires pre-embedded trainings. And because of these limitations, there are modern alternatives called BERT. And yeah, LLMs, obviously, you all know that they capture huge contexts, like 2.5 million tokens. Token is usually just a fancy word to say that it's a word. Modern models can handle multiple word meanings, which is also very important. This is cool to know that each word can mean different things. And they work on something very similar, not on word embeddings, but on text embeddings. And text embeddings are essentially, instead of capturing a vector for a word cat, it can capture a meaning for the whole sentence or paragraph or whatever. The cat set on the mat can be also a vector, which is obviously much more useful for us. And I want to remind you how it all started. I wanted to analyze our documents and understand what's written in our documents. And similar texts now get similar vectors. This is a magical thing. We can feed ChatGPT huge text, and it somehow will collapse it to 1,586 dimensions, even though there are probably thousands of words in this text, and even more meanings, even hidden ones. And it can compare documents, paragraphs, sentences, whatever we want. And what is important, they can be used for semantic search, document clustering, question answering, exactly as we need it, and text classification, right? So, how does the pipeline look of text embedding look? First, you split text into tokens, and again, it's essentially just a fancy word for words. Sometimes it's not, but let's not dive into it. Then it can process through neural network layers. Again, this magical picture, orange, green, red. I'm trying to explain something here, but not really. Then it combines token representations. So this is the important part. So essentially, it's a many Word2Vec implementations in a huge chain. Like if vector is here and is such, and vector is here is such, we can combine them somehow. And now it will output fixed size vector. At least it's how popular models like text embedding other OO3 works, sentence BERT, and universal sentence encoder. In my demo, if we will have enough time for it, I will use text embedding other OO3 to demonstrate how the thing works in actual code. Why do we need embeddings? Well, obviously, embeddings convert text into numbers that capture meaning, and similar text gets similar vectors. It allows us to find relevant answers to users' question. And for reg workflow, which I will be talking about a little bit later, also what's important, it's not only a search, but also a summarization. Because if you think about it, we already compacted a lot of meaning into this double vector. We are not obligated to put this text from this vector as is. We can actually summarize it in a very compact way. We have a compact way to store it. We can explain it in a compact way too. But the next question I asked my friend, do you still remember my friend? Can't we just save data in a database and ask LLM to access it? Like, dear ChatGPT, I have a Postgres with all my data here. Please read a document from there, like all the documents you need. And the answer was no. It was another thing I didn't really understand. The whole neural network thing, I thought of it as of a program, but it's actually a bunch of hard code. Actually, hard-coded weights. It doesn't mean that there is a programmer who sits and writes these weights for each, I don't know, line. But there is a program that finds the best weights for our model. And there is nothing, like, there is no logic. There are no ifs, elses, and so on. Only, let's say, additions and multiplications in this or another way. And it means neural network can't access anything directly. It's more of a data structure than program. And here is the first time when I actually heard the magic word RAG, Retrieval-Augmented Generation. Essentially, the idea is to mix all the relevant data into prompt and make LLM use it. So imagine you do not know anything about RAG, but you can write an essay about, I don't know, e-commerce, how it works. So you're going into ChatGPT and writing this essay about e-commerce, all this warehousing, logistics, and so on. It's probably a long thing. And then you ask, okay, ChatGPT, now when you know all this, please answer only from this text. How does a courier in our e-commerce shop finds the optimal route between customers? For example, you're Amazon. It's an important question. What's the best possible route to deliver parcels to your customers? And for sure, ChatGPT will analyze your text and will answer the question. RAG does essentially the same. But the pipeline is a little bit more convoluted. First, we need to convert our documents to embeddings. You already know something about embeddings, so documents are kind of simple. Then we have to store them in a vector database. Pasha, what is a vector database? Vector database is just a database which can perform some operations on vectors. For example, compare similarity of vectors. Like, is this vector like this vector? Are they somehow related or not? Then, when the user asks our question, we also convert the user query to embedding. Then we find the most similar documents in our database, similar to the query of user, and we put these documents into the prompt, and now user can actually ask questions with documents from this prompt, not even knowing anything about documents. Not all documents can be converted to embeddings directly. The thing is, a lot of documents are too big for traditional LLMs. So we will need to split them into chunks. For example, for OpenAI, it will be 8,191 token. I don't know why it's not beautiful number, 8,192. It is what it is. I don't know. But because Mistral somehow managed to fit this one additional token in their model. I don't know. Again, not a specialist in the whole low-level stuff. And we also have to balance the chunk size. And this is actually tricky. And we won't talk about it today, because why do we need it? If the chunk size is like one sentence, the LLM won't be able to capture all the meaning of the context, right? But if the chunk size is too big, then much will be less precise. Imagine you have 8,000 tokens, which are actual words, and you have to convert them to 1,000 doubles. Obviously, you lose something. If you wouldn't lose anything, it would be just a compression, and it's not a compression, and it's almost impossible to compress this good, I think. And it means that some information may and we probably will be lost in conversion process. We should be careful about it. The second point is to store in vector database. I already said that vector database is just a database that can perform some operations, for example, similarity search. It also should be optimized probably for high-dimensional data. Oh, by the way, if you think that it's something commercial, then no. Postgres has free extension called pgvector, and I will use it in today's demo. It's like just use it, and it probably can store metadata alongside vectors, because it's not enough to know what the vector is. You should store the source text, probably some text, and so on. Here is a small demonstration of what is a cosine similarity. Cosine similarity is a dot product of two vectors. What is it? I forgot the word. By magnitudes or by product of magnitudes of these vectors. And if we have three similar words, rose and sunflower and sun, we obviously can see that they have some similarities. But LLM, the cosine distance, will tell us that actually sunflower is closer to rose than sunflower is to sun, probably because they are both plants or something like this. Which means the smaller cosine distance between our vectors is, the more similar distances, or the more similar meaning is of the words. And there are many different commercial and free vector database, Chroma, DB, VV8, Pinecone, Milos, and pgvector I already mentioned. Now, I want to talk how I actually implemented the software I was talking about, that one to look through our documents. So essentially, it's a very simple Spring application with the following flow. I, administrator, upload documents to the application. It gives me back embeddings for this. It goes to OpenAI, gives me embeddings. And then I save embeddings plus source text into the vector database. And the same happens with the user query. You already kind of hopefully understand what are most similar documents. It's just, but we need not only the documents themselves. Usually we need to get from our vector database the similarity score, because sometimes we can say, please find me 3 most relevant documents to the user query. But sometimes we need something different. I need to find all the documents this close to the user query. And this is slightly different, obviously, right? And optional metadata. For example, if we need to somehow distinguish code blocks from usual text, we want our code blocks to be marked as code blocks, and so on. Then we will feed relevant documents to LLM as a context, as in prompt, exactly as I said during the e-commerce example. Now, sorry, this one is big again. But this is how the thing works from the user perspective when the user works with my application. User sends a query to my backend. Backend resends the query to LLM, for example, ChatGPT. LLM returns embedding. Then, with this embedding in hands, backend goes to vector database and says, find me relevant documents to this embedding. and the vector database returns relevant documents, obviously. And then backend goes to LLM and says, look, here is my original user query and relevant documents. Please summarize or answer the question or something like that. LLM sends answer, and we return it to the user. Now it's time for a demo. Let's try. So this application is written in Kotlin just because I wanted to use Ktor client. The first thing we should do is to save a document to our database. How we do it? Obviously, we have this post mapping, hopefully familiar to all of you, function store document, which accepts multi-part file, and it uses unstructured client. Oh yeah, I should tell you about unstructured. Sometimes it's tricky to cut documents in chunks because, well, I don't know how to do it. Let's say the source document is just an HTML. Can I cut in the middle of a tag or not? Unstructured cares about it for me. If we look at unstructured client, it's actually a huge spaghetti, because unstructured essentially has only one function on the API: submit form with binary data. And it accepts files, coordinates, encoding, and a lot of things. And here, for every argument they accept, I have an argument in my function, and most of them, as you can see, are optional, like, do I need some specific model name or not? And if I don't need it, I won't send it to unstructured at all. What they return to me? They return to me just an HTTP response. I can do whatever I want with this HTTP response, so I will actually convert it to JSON with some data. Then, please, wrong one. This is a config in my application to work with unstructured, just because I need a key for the API and some endpoint I will use. I also have these models. The most important model is, unstructured response, which contains type of response, text of our document, and metadata of this document. We'll look at metadata a little bit later. Now, going back to our controller. We made the response. We received some documents. Document is a Spring internal abstraction which stores a lot of things, but the most important thing is embedding in the text itself. And we can see that I put response text into text of the document, metadata, I convert it to map, and so on. When I have my documents, I say, vector store add documents. And I like how beautiful it is. So what documents are? Is from the beginning, there's just a bunches of text. Well, yes, unstructured somehow processed them, extracted actual text from them, removed all the clutter and so on. But here I just say add documents. And at this point, Spring hides all the magic of going into the ChatGPT or Ada 003, asking it for embeddings for this particular chunk of the document, and then it saves this embedding to this document, and then it saves the whole document with embeddings, text, and metadata inside our vector database. Then I just respond with empty thing. The second function I have in my controller is query. Obviously, I as a user want to query my database and ask questions about my documents. This is how it all started. So the first thing we should do is construct the query to database, and I like how it is a fluent API and not some crazy, I don't know, JPA or JDBC request, because Spring, again, abstracts out of us all the complexities of all the databases. Because the usual thing we need to do is get top K, top N relevant results. And this is just search request.builder, query top K, and then build. Then I say vector source similarity search with this query, which is kinda speaks for itself, hopefully. Please find me relevant documents to this query. Yeah, sorry, I forgot to say that. Obviously, query is constructed with the request param, what I'm asking. Then I construct the whole prompt, and I have this fancy delimiter here, just to be sure that I use unique delimiter not used anywhere in my documents for ChatGPT to be able to distinguish different documents from each other. And content of each document will be title of this document, like this, and then the body of the document, which is kind of obvious. Then we have the system prompt template, where we explain how our documents are structured, what is our delimiter. Also, we instruct, and this important part, if there is no information, you answer with this, sorry, I do not have such information, because no one likes hallucinations about their own documentation. And it would be a shame for me if I would be like a developer advocate telling you lies just because the lie was told to me by ChatGPT. Then we create system message, which is just a Spring abstraction of system message, because there are multiple models that can work in slightly different manners, and user message template, and then we create user message itself and prompt, and then we say, this is an important part again, chat client, prompt, with prompt, call, get me content. That's all, like, this is the whole flow. Let me try, oh my God, what's going on here? I don't like it. It will be cheating. Let's kill this and recreate it again. Nice. Now I should start my application, and hopefully it will create all the tables for me in Postgres. Obviously, it always takes some time to compile. We are started. Nice. Now, let me try to maybe upload a couple of documents in there. How do I do it? Something like, it was my experiments. Nope, nope. Yes. Are you doing something? So I have a description of our Liberica Performance Edition. It's just a Java Java 8 running on top of JVM 21. We can look into it actually. The document, not Liberica, I mean. Just a usual HTML document with a bunch of stuff we are not interested in. JavaScript and comments and styles and so on. When we uploaded it, it was like, yep, did it. Now we can try to ask some question. At least try. What versions, I don't know. No, not like this. What is Liberica performance? Sometimes it doesn't work, it will be a shame, but hopefully, at least we'll try. Thinks for some time. Yeah, and Liberica Performance refers to Liberica Performance Edition, which is designed to bring some of the performance enhancements of JVM 17 and JVM 21 to projects that can't fully migrate, and so on. Let me show you what happens in my database. It's actually very simple. Oops. Why? Yep, we are there. So it was originally one HTML document, as you remember. Now it's 2 rows in my database with some metadata file type, languages, and so on, file name, and also its content in like as a pure text, without all this HTML clutter, which makes it much cheaper for LLMs to still a lot of things, because obviously there were a lot of meta information on this HTML page, but a lot of it is actually useful. And unstructured I/O cut all the documents for us and gave us an ability to put the whole thing into database in a kind of structured way. We also can see here embeddings, just along vectors of numbers. And now LLM can actually answer our questions, sorry. And this is how you do it. You can do, obviously, you can do the whole thing without unstructured if you want, because there is a ticket document reader in Spring AI 2. So you will need to tune it a little bit to say what's your size of the context window and so on. Other than that, it will work similarly, and it's not a third-party API. Everything depends on your conditions. I would say that unstructured cuts better and extracts text better, gives you more useful meta information. Other than that, well, I think you can totally go with the ticket document reader. Summary. First, in my opinion, RAG is actually very simple. As you saw, the whole RAG pipeline fits into one small class. It could be written in Java, it's written in Kotlin, it will be the same amount of lines in Java actually. But you need to know what is embeddings and to understand RAG a little bit, just for it not to be magical. It shouldn't be like, oh, it is a vector database, I don't know what's there. There are vectors, and there are ways to compare similarity of these vectors. And Postgres knows how to compare similarity actually, and it can build indices on top of these vectors and so on. Embeddings are not any magic. Hopefully, those of you who raised their hands when they didn't know what are embeddings at the beginning of the talk now have some slight idea about what it is. And you actually don't need to know how LLMs work with all these forward something layers and different kinds of layers to use RAGs in your actual job. Imagine you have a complex software and a lot of documentation for it. Probably you can take my code and reuse it today at your work, and tomorrow you will ask your useful AI assistant, maybe it's in some nice web interface, maybe not, something about your business. And it will answer, because all the data is there. If you're interested, there are a couple of QR codes. First part is the blog post on top of which this talk is given. The second one is the actual source code on GitHub. I updated it yesterday to latest Spring AI 8th milestone, just to be sure that it will work for all of you. Latest Kotlin, latest Spring, latest all the stuff. I'm sure that it works at least currently. If you have questions, well, we'll read some questions from Slido, probably if there are some, if there are any. Here is also Slido QR code. You can scan it, you can ask questions there. Also, you can find me on social networks. I will try to share the slides for these presentations today or tomorrow somewhere on Twitter or Blue Sky. Now, I was told that I have to switch back to Slido thing. So now we are there. Thank you so much. I don't see any questions, so it's your time to ask them. Or you can just say me, thanks, Pasha, and goodbye.